Hi, I'm Pascal Ventropot, Senior Director Innovation. I'm here with Mario.
Senior Partner Solutions Architect, AWS.
And Garvan.
I lead the Applied AI team at Anthropic.
And we are here to talk about how to build a Gen AI application with AWS, Confluent, and Anthropic. Let's start with a powerful insight. 79 of IT leaders agree that data streaming is key driving business agility. This shows how organizations have recognized the need for real-time, actionable data and stay competitive. But despite this recognition, managing real-time pipeline, integrating system, and ensuring security at significant complexity. Let's look at what's holding businesses back for unlocking its full potential. From a lack of in-house technical skill to data silo, these issues prevent organizations from unlocking the full potential of their data. Add to that the growing complexity of governance and increase of user expectation with generative AI. It's clear why many businesses struggle. The question is, how can we overcome this challenge? Let's take a look at the architecture that needs to be solved to solve this. This brings us to the concept of a modern data architecture. At the core is data governance, ensuring data is secure, compliant, and accessible. Surrounding it are key elements like data warehouse, streaming analytics, and generative AI application, all of which work together to make data more useful and actionable. This holistic approach is what enables organizations to break down silos, scale AI, and meet rising demands. But how do you start building such an architecture? That's where understanding your specific challenges become essential. Let's pause for a moment to reflect. What do you see as the biggest challenge in leveraging real-time data for AI application in your organization? Please raise your hands. Is it data silo? A lack of technical skill? A governance issues? Or a scaling AI application? Ultimately, data isn't just another business asset. It's your differentiator. And I'm here with Mario for him to talk about it.
Merci. Creating valuable AI applications requires understanding your business and your customers. Your data transforms generic applications into domain-specific tools. While organizations recognize generative AI's potential, many focus on foundation models or LLM models. This approach overlooks crucial components. Data enables generative AI value through multiple means. Operational databases handle user interactions. Analytics and data lakes store domain-specific information. Real-time streaming and batch processing keep current data. And a modern data architecture incorporates data integration, quality control, privacy compliance, and security measures. Proprietary data differentiates Gen AI applications. While companies access similar foundation models, success comes from leveraging unique data assets for agents, code generation, and document summarization. Organizations can optimize Gen AI with proprietary data using these three techniques. With retrieval augmented generation, you augment prompts with external data. For fine-tuning, you create specialized models using domain-specific data. And continued pre-training extends model knowledge using enterprise datasets. For example, an online travel agency can generate personalized itineraries by combining real-time flight data, customer profiles, current inventory, and historical preferences. AWS provides comprehensive services for generative AI, supporting unstructured, structured, streaming, and vector data. It enables integration across sources and ensures data lifecycle security. AWS offers infrastructure, secure foundation model access, and development tools for GenAI applications. Amazon Bedrock provides managed access to foundation models from AI21 Labs, Anthropic, Cohere, Meta, Mistral AI, Stability AI, and Amazon. It enables experimentation, customization, and agent creation without code. Bedrock prioritizes security and privacy through several measures. It ensures customer data isn't used in base models. Fine-tuned models remain private and secure. All data is encrypted with access controls matching AWS standards. And the platform supports HIPAA, GDPR, SOC, ISO, and CSA compliance. Guardrails from Amazon Bedrock implement safety measures across foundation models, allowing topic restrictions and content filtering based on organizational policies. Knowledge bases for Amazon Bedrock offer comprehensive functionality. It manages RAG workflows automatically, integrates real-time and historical data sources, maintains conversational content, and provides source citations to reduce hallucinations. Garvin Doyle, head of applied AI at Anthropic, is our next speaker. Anthropic is known for ethical AI development and collaborates with AWS on advanced AI applications such as retrieval augmented generation.
Thank you so much. Hi, everyone. Just a quick show of hands. I'm curious, has anyone heard of Anthropic? So I was at reInvent last year, and I think about 3 people put their hand up, so that's a fantastic improvement. So Anthropic is a foundational model provider. We create large language models, but we do so with a focus on safety and interpretability. I think oftentimes people hear safety and the concept of cloud computing and AI, and it has a muddled definition of what that might mean. To us, that really means this first bullet point here, which is interpretability. How well can you understand what these AI systems are doing, how they think, and how explainable are they in their outputs? These other bullet points you see on the slide here are the 5 core pillars which Anthropic uses to guide its AI development process. As you can see, aspects of this, i.e. the first 3, are core to building language models. They're research within the model itself. Interpretability is understanding how the model works. Alignment is ensuring that the model is better at following our instructions and working on tasks that we would like it to work on. Pre-training is the aspect of adding these new capabilities into the core underlying model. And then the bottom 2, enhancing retrieval and agentic orchestration, are aspects that we include through external systems that we might engineer around the model. Specifically to today's conversation, we're going to talk a bit about enhancing retrieval. It's a core aspect of any generative AI application, and I think it's one that often gets overlooked or oversimplified. So this is a canonical example of retrieval augmented generation, sort of your standard RAG pattern, if you will. There are several core weaknesses that we've sort of seen emerge over time with customer deployments and different applications for this type of architecture. The most common failure mode we see is poor retrieval performance. And without proper evaluations, it's really difficult to decipher if this performance is coming from your model or your retrieval system. When retrieval is the issue, the root cause is one of 2 things. It's either missing data, so you're retrieving over data that is non-existent, or it is query and corpus embedding misalignment, meaning the mechanism you're using for querying your data is misaligned with that actual data. So Anthropic has spent a series of efforts with our research team on improving this concept with a new paradigm that we're calling contextual retrieval. Frankly, it's not a very complicated concept. The keen-eyed audience members might recognize this pattern as it looks somewhat similar to hypothetical document embeddings. But you may also notice that it is slightly inversed. So what's happening here? We are augmenting the retrieving of chunks, but these chunks are not the naive segments of a document. They include summarizations of how that chunk is situated within a document. What that might mean is, we are searching over a set of financial results, perhaps, and we want to know the financial results, how they are relevant or how they pertain to a specific temporal range, let's say last quarter or last year. If you just simply or naively chop up the document into 500 token chunks, you're unaware of where that chunk is situated within a document. Is it in the 2024 report? Is it in the 2004 report? It's very important information to situate that context. So simply what we're doing there is taking the chunk, summarizing the document as it pertains to that chunk, and using that as our embedding to be retrieved upon. To make this process cost-effective, we leverage prompt caching. So as you could tell, in processing or in the pre-processing step for contextual retrieval, you need to append the entire document into your context window. Large language model providers such as Anthropic charge based on input and output tokens, so clearly there's a cost associated with this that didn't exist before. Technologies such as prompt caching allow you to mitigate a lot of that cost because prompt caching allows you to cache or compute the tokens for the document only once. This means that the additional or incremental tokens that you use are simply the chunks themselves to be situated within the document. This drastically reduces the cost and actually makes this a viable technique at scale. And not only is it sort of viable at scale, you can see from this input, it's actually not that far from the traditional RAG canonical example I showed earlier. You're still using a re-ranker, you're still reusing rank fusion. You're simply doing this at the onset or the ingest aspect of your data pipeline. For the re-ranking component, we often say that there's re-rank models out there. There's many open source models. It's also pertinent to consider using a language model that allows you to query log probabilities for re-ranking. Oftentimes, you can see this entire diagram feeds into a re-ranker. It would not make a lot of sense to put a very unintelligent or naive model at that point in time, especially if you're navigating over several retrieval paradigms. Maybe you're using contextual retrieval, maybe you're using an SQL database. This re-ranker model's job is to filter through those different sources of data and provide the most relevant subset of that. So considering to use language models in more aspects of the chain is important, and that's a great area to focus on. So you can see from our results here that the failure rate or the missed retrieves drops dramatically from just a simple embedding RAG approach to contextual retrieval. You could imagine at scale when you have many millions of customer interactions, this would make meaningful impact. Something I wanted to touch on beyond just the retrieval mechanism of contextual retrieval is how RAG is actually used. Oftentimes we describe RAG as a method for bringing data into the context window so that you can answer questions about current data that maybe is not in the model's training. It also works extremely well for reasoning tasks. So there are scenarios where you're not looking to simply pull in the correct data and provide a cited answer. You're actually looking for the model to do a complicated task. You can imagine understanding a tax process, understanding a tax code, legal documentation. There's a lot of these newer use cases that are leveraging the language model's increasing reasoning capabilities. But there's ways to use RAG and in-context learning to make that even better. So simply put, in-context learning is few-shot prompting. It's providing examples in your prompt on sort of what the task is at hand. Leveraging RAG for in-context learning allows you to dynamically pull in examples that are pertinent to the query at hand. So instead of you choosing the 5 best examples that describe how your task works, you'll actually sort through a database of examples and pull in the most relevant 5 given the task information. Something that, if we look here, so something that has become quite apparent is that as models are released on an increasing, on a faster and faster timeline, it's becoming difficult to optimize prompts around these ever-changing base models. What you should focus on doing is building a robust system around the model itself. This is really where I think retrieval augmented generation shines in comparison to something like fine-tuning. In this sort of flywheel example, you can see that we might use a subject matter expert to write down some golden examples or some true examples about a reasoning task. Let's say the task is understanding your tax return, trying to better understand why you got the specific refund on your tax return. We're going to then put that into our database, and at runtime, when someone provides their tax return, we're going to pull the 5 most similar tax returns and the annotations from the subject matter expert. What this allows you to do is now you've built a system that is actually, you can scale the quality of the outputs of the system without affecting the model, the prompt, really any of the brittle aspects that are related to generative AI. You simply append these examples into a database, and this allows you to increase the quality without sort of overly tuning prompting. I think the best way to understand this is to build it yourself. And I'll now pass it back to Pascal, who can describe how you can build this system with Confluent, Bedrock, and Anthropic's language model, Claude. Thank you so much.
Thank you very much. Here we see how Confluent play a pivotal role in enabling data streaming to power AI application with Amazon Bedrock. Confluent ensures seamless, real-time data integration across systems, breaking down silos and enabling a consistent flow of data. In this reference architecture, Confluent is a backbone that connects streaming ingestion, data lakes, and batch processing, ensuring data is delivered to the right place at the right time. Without this foundation, integrated generative AI application will be far more challenging. Confluent ability to provide real-time data streaming is crucial for enriching generative AI application with up-to-date context. In this architecture, Confluent integrates directly with vector database to ensure conversational AI systems like chatbots always operate with the most relevant real-time information. This capability is what differentiates Confluent. It's not just about data movement. It's about ensuring that the data is current, contextual, and ready to drive AI decision. Well, we're going to now talk about Flink inference. It's a key technology that powers AI application on Confluent Cloud. So Flink inference enables real-time AI ML prediction by leveraging Flink SQL. It simplifies integrating machine learning into application, delivering instant insight, and empowering real-time decision-making with accurate, up-to-date data. Here is an example of configuration using Flink inference with AWS and Anthropic. The first thing you're going to have to do is to create a connection between your Flink and the model. So it's done by using the Confluent CLI. And as you can see, you can define the different endpoint and some API keys. You can use, obviously, different model. In this case, it's a Claude, but we support different version of Claude and different model. The command line in the middle is that when you create a model in Flink itself, that's allowing you to define predefined prompts, for example. So if you want to use constantly the same prompt over and over, but different flavor of parameters, you can define a base prompt and then just customize it at runtime. And the last one below is just how you're going to insert your data by calling the ML predict function, and you give the parameter you want to use. It's pretty simple, right? Here is an architecture. So documents or metadata are first published to a topic, like you can see on step 1, forming an entry point for processing. If needed, the document is split into smaller chunks to enable parallel processing and better efficiency. Next, embeddings are generated for each chunk using Bedrock or Anthropic models. These embeddings, along with the chunks, are then indexed into a vector database, like MongoDB Atlas. To help you get started, we've created a quick start leveraging this setup. You can scan the QR code just right there, and you will go to a Git repository that you can deploy this quick start on your own infrastructure. One of the interesting things in this quick start is we index structured documents into a vector database. So there is some step, for example, to take the structured data and ask Claude to generate a summary of that structured document to be able to be indexed and queried by human language. In this one, the chatbot interaction begins through an API or a Kafka client. That's enabling real-time communication. Embedding are generating from user interaction and retrieve relevant documents from a vector database. Using these documents, along with the context and any available real-time data, a prompt is crafted to ensure accuracy and relevance. This engineered prompt is processed by Anthropic Cloud to generate a precise context-aware response. To further enhance efficiency, the ongoing conversation can be summarized, reduce complexity, and optimize LLM performance. So when you go to the quick start, we do some extra step, and especially it's to ask Cloud to generate a more compliant request for vector database search. And that we notice that we have a much better result than just like sending the human request to an embedding and use that for retrieving the documents. So why using Flink? It connects to a vast ecosystem of tools and is cost efficient. It offers real-time data processing, integrates seamlessly with models like Anthropic Cloud, and is easy to use with Flink SQL. It's fast, reliable, and scale automatically to handle massive workload. All these let you focus on innovation without worrying about infrastructure. Confluent not only integrates with all major AWS services, but it also integrates with major data warehouse like Snowflake and Databricks, but also vector database like MongoDB.
And Confluent is also certified and validated by AWS for a range of AWS services and use cases.
And as most of you are aware, all of Anthropic's models are available on Bedrock. Amazon is a strategic partner to Anthropic, so we're working continuously with them, not only at the product layer with things like Bedrock knowledge bases, but also the whole way down to the silicon layer to ensure we stay on the frontier.
So you can get started with Confluent on AWS Marketplace for free. You just have to scan the QR code.
And the middle QR code leads you to an Amazon Bedrock knowledge base workshop where you can learn how to do RAG with knowledge bases for Amazon Bedrock.
And the final QR code brings you to sort of a quick start guide for using Claude in Bedrock.
Thank you so much. And if you have any question, just ask. I can't see anything. Thanks.